Domain of composite functions. Now that we've considered how to construct composite functions by plugging one function into another, we need to consider what consequences that has for the domain of the subsequent function. When considering the domain, there are two steps. First, we need to find the domain of the inside or input function. If there are any restrictions on the domain, we write them down. Second, we construct the composite function. Then we find the domain of this new function. If there are any restrictions on this domain, we add them to the restrictions from step 1. If there's any overlap, we always use the more restrictive domain. Once we have the domain of our new composite function, we can use that to generate the range as well. Continuing on with our example from earlier, let's consider the functions f of x equals x squared, g of x equals e to the x, and h of x equals the square root of x minus 2. We want to find the domain of each of the following compositions. The first one is f of g of x. So our first step is to write down what the inside function is. In this case, it's g of x, which gives us the function e to the x. So we think about what the domain of this inside function would be. E to the x has a domain of all real numbers. We can plug in anything we want into e to the x without any problems. So we'll say that x has to be between negative infinity and infinity. Again, we don't use the equal sign with the infinities. So our domain is everything. So now let's consider the new function, which is our composite function, f of g of x. So we take our g of x and we plug it into f of x, and we get e to the x all squared, which we said before was the same thing as e to the 2x. Now when we think about the domain of this new function, it's going to be the same as the domain of e to the x, because if we multiply anything by 2, that's not going to change the fact that we can plug in anything we want. So here, the domain of the new function is also all numbers between negative infinity and infinity. So now we look at the domain of the inside function and the new function to see if one is more restrictive than the other. It's not, and therefore the domain of the composite function will also be all numbers between negative infinity and infinity. We're going to do the same process for the rest of these. So let's move on to g of f of x. First, we start by writing down the inside function, which is f of x. That function is x squared. The domain of x squared is going to be all numbers. We can plug in whatever we want here. And then our new function from our composition is e to the x squared. And again, we can plug whatever we want into e to the x squared. So the domain of the composition is all numbers. And so therefore, since it's the same domain and one is not more restrictive than the other, the domain of the composite function is all real numbers. When we get to h of f of x, things start to change a little bit here. So f of x, again, the inside function, is x squared. And so the domain of that is all real numbers. However, our composite function now, we have to plug x squared into the square root of x minus 2. So we get the square root of x squared minus 2. Thinking about square roots, when we think about domain, we have to be really careful because we don't want whatever is underneath the square root to be negative. So it's really important that x squared minus 2 is always greater than or equal to 0. Well, if x squared minus 2 is greater than or equal to 0, we need x squared to be greater than 2. So here, we can write x squared has to be greater than or equal to 2. And we can use that to set up our domain. So if x squared has to be greater than or equal to 2, that tells us that x either has to be greater than the square root of 2, or x has to be less than or equal to negative square root of 2. Anything in between negative square root of 2 and positive square root of 2 is going to result in a negative number underneath the square root, and that won't satisfy what we need. So our domain here is more restrictive on the composite function than the inside function. So that's the domain that we use for the composition. So x is going to have to be greater than or equal to the square root of 2, or x could be less than or equal to negative square root of 2. If you're unsure how we got those, try testing some numbers to make sure it makes sense to you. If you try something like 5, you'll find that the square root is going to be a positive number, which is what we need, and 5 is greater than the square root of 2. If you pick something less than negative root 2, like negative 10, and you square it, you get 100 minus 2, which again is a positive number. And if you test anything in between, you'll find that whatever is underneath the square root ends up being negative. So we don't want anything between negative square root of 2 and 2. So let's move on to the next one, h of g of x. So again, our inside function is e to the x, and e to the x has the domain of all numbers. Our new function, our composite function, is the square root of e to the x minus 2. So again, we have this square root conundrum where we need that whatever is underneath the square root is going to need to be positive. In order for something to be positive, it has to be greater than or equal to 0. So we need to set e to the x minus 2 to be greater than or equal to 0. The result of that is that we need e to the x to be greater than or equal to 2. As long as it's bigger than 2, then the result under the square root will be positive. But we want to be able to define this in terms of x. So algebraically, we can use natural logs on both sides to bring the x down. If you take the natural log of e to the x, the natural log and e are reciprocal functions, and we get that x has to be greater than or equal to the natural log of 2. Because when we take the natural log on the left, we also have to take the natural log on the right. So our domain here is more restricted on the new function, and therefore that will become the domain of the composite function. We need x to be greater than or equal to the natural log of 2. Our final function, h of x, is a little more tricky. So here, the inside function is h of x, which is the square root of x minus 2. In this case, we need x to be greater than or equal to 2. If x is greater than or equal to 2, then what's under the square root will be positive and we'll be okay. The new function, our composite function, is the square root of x minus 2, all minus 2. So that means that we need the square root of x minus 2 to be greater than or equal to 2. So the term on the left has to be bigger than the term on the right when we're subtracting in order to keep it positive. So again, we'd like to write this in terms of x. So we're going to square both sides. That will hold the inequality. So we get x minus 2 is greater than or equal to 4. So when you square a square root, the square root goes away. And when you square 2, you get 4. Solving for x gives me that x has to be greater than or equal to 6 because I added the 2 from the left over to the right. So I look at my two different domains to figure out which one is more restrictive. X greater than 6 is more restrictive than x greater than 2 because there's less numbers from 6 to infinity than from 2 to infinity. So since that's more restrictive, the domain of this composite function is that x has to be greater than or equal to 6. If you'd like to convince yourself, try plugging in 6, 7, 8, make sure it's all positive, and then try something like 5 and see what happens if you run into any trouble. That should be enough to convince you that this is the right domain. Example 8. Because the square roots are so tricky, let's try another one to make sure we got the algebra down. So consider f of x equals the square root of x minus 2 and g of x equals the square root of x squared minus 1. We want to find the domain of the composite function f of g of x. So we start with g of x. We write down what g of x is. G of x is the square root of x squared minus 1. The domain of this function, again, needs for whatever is underneath the square root to be positive. So we have x squared minus 1 has to be greater than or equal to 0, which means that x squared has to be greater than or equal to 1. So again, if we consider the cases on each side, the root of x squared is 1 and negative 1. So that tells me that the domain is that x has to be bigger than or equal to 1, or x could be less than or equal to negative 1. Again, if you're not sure, try plugging in a couple of numbers, and this should convince you. So that's the domain of the inside function. Step 2, we have to figure out what our composite function looks like. F of g of x means that we're plugging in g of x into our f function. So therefore, whenever we have an x in our f function, we're going to substitute in our g function. So we have the square root of x squared minus 1, all minus 2. So again, whatever's underneath the square root has to be greater than or equal to 0. So we have the square root of x squared minus 1 minus 2 has to be greater than or equal to 0, which means that the square root of x squared minus 1 has to be greater than or equal to 2. So again, to get rid of the square root, we can square both sides. So here we have x squared minus 1 is greater than or equal to 4. On the left-hand side, when you square a square root, that goes away. And on the right-hand side, 2 squared is going to give you 4. Again, I can square both sides because I'm dealing strictly with positive quantities. This doesn't work the same way with negative numbers. So here, I'm going to add 1 over to the other side, and I get x squared is greater than or equal to 5. So now that I have that, again, I have to consider the cases for x based on the square root. If x squared has to be greater than or equal to 5, then x needs to be greater than or equal to the square root of 5, or x has to be less than or equal to negative square roots of 5. So again, we're thinking about a number line and thinking about what's more restrictive. So the more restrictive domain is going to be that x is greater than or equal to the square root of 5, or x is less than or equal to negative square roots of 5. Now, when I talk about the number line, sometimes it's a good idea to graph it out on a number line if you're not sure where things fall on the number line. So for example, if I take my original domain, that says that x has to be less than negative 1 or greater than 1. Now, if I were to add on my root 5 and negative root 5, the square root of 5 is approximately 2.2. So that means that somewhere over here is the square root of 5, and somewhere over here is negative square root of 5. So now, if I'm saying I can only include numbers there, that's more restrictive because it's not even including this. So our final answer here is that for the composite function, our domain should be x is greater than or equal to square root of 5, or x is less than or equal to negative square root of 5.